Hello everyone, I'm Kintree, and today I made this video about a problem that I think is quite interesting. And for those of you who did not learn logarithm yet or forgot how to use them, we only need to use this three properties of logs, and um, that's it. So I think anyone can enjoy this problem. So for those of you who want to actually try this, please pause the video and feel free to try the problem. This is a solution to this problem. This is not too complicated because this problem is not from a workbook that is extremely hard, but I think it is quite interesting, so I brought it here. So at first, when I first looked at this problem, I actually did not know what to try. So I actually tried to write everything that I know, even though that's not really an ideal thing to try. First, I know that log x is equal to f of x plus g of x. And now uh, f and g, they are functions, but one thing to know is that function is a relation, it is not an equation. So we need to know that this is a relation. So the relationship between f of a and log a and g of a and log a is that f of a is the integer part of log a, and g of a is the decimal part of it. And also, we only look at the positive part when we actually say as decimal part. So, for instance, negative 1.5, the decimal point part is not negative 0.5, but this is actually 0.5 because it is negative 2 plus 0.5. So this is just one thing to note. And so when I resume it, I also know that log y is equal to f of y plus g of y, because that's what the problem actually shared to us. And now I actually quite want to use this property, this characteristic that the problem gave us. So I actually tried this, log 1 over y. And this one, when we plug in to that, I will say, equation, I can get that this is true. Now, I want to manipulate this quite a bit. So actually, we know that this is equal to log y to the power of negative 1. So anyways, if we use this property right here, we can know that this is equal to this negative 1. It is negative log y. Now, when we go back to that part, we can know that this negative log y, so I can write this as gy. There's nothing wrong with this, right? So when I rewrite this, it is negative fy minus g of y. Now we also know that these two are the same numbers. So actually, their decimal points and this decimal part must be the same. Because this is a number, because these two are the same, since these two are the same, their integer part and decimal part must be the same, because yes, because they're the same number. And now I want to fix this like this. Now the reason why I did this is because it will be more clear when we look at it this way. So actually, I just subtracted 1 and added 1 again, so nothing changed to this expression. And this is the decimal part of this, because this is positive number. So when we look at closely, this part, the decimal part, and this decimal part, they are the same. So these two are the same. Now, I actually want to rewrite that one, because since they're the same, I can write this as g of 1 over y is equal to 1 minus g of y. Now we also know that g of 1 over y is equal to g of x. So when I rewrite this, is gx is equal to 1 minus g of y. And let's make this look more clean. We can know that g of x plus gy is equal to 1. So this is the one thing that we know. And now, since we have nothing to do, let's just try to use this one. So we know that log x squared y cubed is equal to 12.5. And because we know that we can separate log like this, I can also make this equal to log x squared plus log y cubed. Now I want to use this property again, this one, so I can make this as 2 times log x plus 3 times log y. They're the same thing, and I just want to change this to f of x and g of x. I want to write this in terms of f and g, so I can rewrite this as this. And now what I want to do is I want to change y into x. No, actually, it doesn't really matter. You can change x to y, but it's just convention that we all have. We use x a lot. So because we know that f of y and f of x, they are equal to each other, I can write this like this. They're the same, so I just change this two. And also I know that g of y is equal to 1 minus g of x. So I can write it as 1 minus g of x. Now I actually want to combine those two, so I can make it like it is minus g of x, sorry, plus 3. Now, because we know that they are all equal to each other and this is equal to 10.5, I can just rewrite this as plus 1 minus g of x plus 2, and you will know why. And the reason why I separated 3 into 1 plus 2 is because I want to make this expression plus 1 minus g of x is equal to 10.5. What I just did from here to here is just subtracted 2 on both sides. And we know that this is the decimal part of this number, and this is the integer part because this is decimal. No, it doesn't have to be, but it should be in this case because we have decimal point here, and this is the integer part. And the reason why we know that this is decimal part is because when we just change that, we can know that negative g of x is less than greater than negative 1, but less than or equal to 0. When I add 1, it is greater than 0, but less than or equal to 1. So it might be 1, this might be 1, or 0 point something something, but it doesn't make sense when it's 1, so we can just conclude that this is just a decimal point of this. So we know that this is equal to 0.5, and since this part is equal to 10, right, because it is 10 plus 0.5, we can know that f of x, this part, is equal to 2. And let's get back to there. So we know that f of x is equal to f of y, that's what the problem gave us, and we also found that they are equal to 2. Now since we know that this whole thing is equal to 0.5, I can just say that 1 minus g of x is equal to 0.5. Therefore, g of x is equal to 0.5. And also we know that when we add 0.5 plus g of y is equal to 1, they're all equal to 0.5. So one thing to know is that it's equal to g of y, which is equal to 0.5. Now, because we know that these are true, we know that log x is equal to 2 plus 0.5, which is 2.5, and log y is the same. And because we need to find x over y, I just wanted to subtract these two. So I got log x minus log y is equal to 0, because when we subtract 2.5 minus 2.5 is equal to 0. When we use this property, we know that log x over y is equal to 0. Then, because there's a hidden 10 here, we can know that x over y is equal to 10 to the power of 0, which is equal to 1. Therefore, the answer for this question is 1. Right? I think this problem was very fun problem to try. It took me a while to actually try to solve it, and I think this was a great problem to review the properties and characteristics of logs. And I think these problems are very fun. So thank you so much for watching the solution. If you have any questions, please feel free to comment this video or comment on the live stream that I do every day. And I think that's it for today. Thank you so much for watching this video. Then see you in the next video. Bye bye.